Hello, I will talk about the project nanostructure pyrite carbon composite synthesis and use as anode material for lithium-ion batteries. I am the author of this project. My name is Luis Sergio Rivera Aguilar. Pyrite has been studied as anode for lithium-ion batteries due high theoretical capacity, and like any metal transition chalcogenide doped with any source of carbon has been proved to increase specific capacity and life cycle. For the material synthesis, in this project were used those reactants that were dissolved in ethylene glycol water solution in this relationship volume. Pyrite composite were synthesized successfully by using a sonication probe at a time of 2 hours 15 minutes with a power of 78 watts and ambient condition, and then pyrite was coated with carbon using a glucose source by solvothermal method using these conditions. This is the equipment used for the material characterization. This is the procedure of fabrication of electrons and battery assembly. And this is the equipment used for the electrochemical characterization. In the results, X-ray diffraction in both cases for the pyrite and the pyrite with carbon, the XRD parent show very high purity and crystallinity. For the scanning electron microscopy, you can see a very uniform morphology in both cases, and with the EADS graph, you can see the respective element found in both samples. For the cyclic voltamperometry, in the pyrite carbon with the configuration 70-20-10 anode, you can see from the second cycle and onwards 2 pairs of redox peaks. And for the anode with 80-10-10 configuration, only you can see only 1 pair of redox peaks. That is because the different amount of material active used in both cases. In this case, the amount is lower than the results shown in the figure number 6. For the galvanostatic charge-discharge test, the 80-10-10 configuration showed higher capacity than the 70-20-10 configuration. And you can see this configuration could resist better the current with the next cycles compared with this graph. And for the galvanostatic charge-discharge test at 0.7 C, the configuration 80-10-10 could resist currents above of 0.7 C. The conclusion of the project, and that's all.